Alright, this video is kind of an advancement of what we can use factoring for within algebra and why it's really an advantage when it comes to quadratic equations. Now you'll notice we have three quadratic expressions on the screen, all of which are ready to factor. So if you want a little bit of practice, feel free to pause the video now and you can factor the three expressions on your own. I'm going to go ahead and factor them on the screen. So if you want to watch along, you can do that as well. And then I'm going to change the question a little bit to show us where factoring can really apply within our algebra. So again, if you want practice, go ahead and pause the video now and work away. All right, for the first expression in the upper left, the biggest thing I would notice is that you want to multiply to 88, but add to 19. And two numbers that do that very well would be 9 and 11. So we're going to say x plus 9, x plus 11. Now you could do that with the other two statements as well, but you'll notice I saw a 9 and a 25 here. So I went ahead and tried the perfect square pattern, saying that 3m squared would be 9m squared, 5 squared is 25, and as long as I want to end up with a negative number in the middle, I better say minus 5. And remember that 3 times negative 5 times 2 will give us that middle. 3 times our negative 5 times 2 gives us that middle number, which means it does fit our perfect square pattern. On the bottom, you could have also factored this using a difference of squares pattern, saying that 10x minus 5 and 10x plus 5 would split this up. I noticed there was a 25 in both parts, so I factored that out as a monomial. Then notice that 4 and negative 1 would be perfect squares. So 4 comes from 2 and 2, negative 1 from negative 1 and positive 1, and I factored out that difference of squares pattern there. Now the biggest thing, or where factoring really applies, is that when we factor an equation, if it's equal to 0, we can use the zero product property, as it's called. If a times b equals 0, then either a or b had to be equal to 0. So if two things are going to be multiplied, such as x plus 9 and x plus 11 equal to 0, then either x plus 9 has to equal 0, or x plus 11 has to equal 0. Thus giving us our two answers. If I subtract 9, negative 9 would be one possible solution to this equation, or x could be equal to negative 11, giving us the other possible solution to this equation. And you found a way to split your equation and find two possible answers that solve our quadratic equation. You can do the same thing with 3m minus 5 squared, or you could just take a square root and realize that, well, if we do split it, 3m minus 5 equals 0, or that exact same statement again. So 3m equals 5, or the fact that you're only going to get one answer this time, divide by 3, and you end up with 5/3. Finally, on the bottom, again, there's three pieces, 25, 2x minus 1, and 2x plus 1. So we can split into our three parts. 25 equals 0, 2x minus 1 equals 0, or 2x plus 1 equals 0, thus giving us the fact that this can't work. 25 can't be 0. 2x could equal 1, so x could be a half, or 2x could equal negative 1, so x could be equal to negative a half. And there are our two answers. Factoring gives us the opportunity to use zero product property, and that property gives us the chance to solve quadratic equations fairly simply. I hope that helps. Good luck solving your quadratic equations by factoring, and have a great day.